Okay, so we're all using AI pretty much every single day. But have you ever stopped to wonder why some of it feels, well, brilliant, while other times it's a complete mess? You know, the secret isn't just about having a fancy algorithm. It's really about the quality of the data it's built on. Today, we're going to pull back the curtain on the hidden world of AI's gold standard.
It's a really big question, right? We hear all these amazing promises about how AI is going to change everything. But then you try to use a chatbot and it can't even handle a simple request. So what's the deal? Well, we often love to blame the algorithm, but honestly, the real problem usually starts way earlier, with the data it learned from.
And a huge part of the answer comes down to this number right here. Believe it or not, a typical raw data set, that's the initial mountain of info you feed an AI, can be anywhere from 30 to 50% pure noise. I'm talking errors, duplicates, totally irrelevant stuff, basically just bad data.
And that, of course, leads us to the oldest rule in computing, which has never been more true than it is for AI. Garbage in, garbage out. It's that simple. If you train a model on messy, unreliable data, you are absolutely going to get a biased, inaccurate, and unreliable model. It doesn't matter how powerful or sophisticated your algorithm is. The foundation is just broken from the start.
So how in the world do you fix a mountain of messy data? Well, you can't just dive in head first. You need a system, a methodical way to sort the good stuff from the junk. And that's where a concept called a data grading system comes in. Think of it like grading exams in school, but for every single piece of data.
So what do we actually mean by grading data? Well, it's a process where every single data point gets systematically checked, evaluated, and then sorted into different quality levels. It's judged on some really strict criteria, like is it accurate? Is it consistent across the board? Can we rely on it? We're basically figuring out how truly valuable each piece of information is.
And what you end up with is this really clear hierarchy. Down at the bottom, you've got grade D. That's the raw, messy stuff we started with. After a bit of cleaning, you get grade C, which is okay for some auxiliary training. Then you've got the good stuff, grade B, which is high quality enough for the main event. But at the very top, that's grade A, the golden data set. This is the absolutely pristine, perfect data that you measure everything else against.
Okay, but how do we get from that giant mountain of junk all the way to that tiny handful of gold? Well, it's a journey of intense filtering and refinement. So let's walk through the gauntlet that data has to survive to level up to golden status.
The whole journey is basically a four-stage funnel. You start wide with some initial automated filtering, then you actually use AI itself for a much deeper check. After that, you bring in the human experts for the final stamp of approval, and only then do you use it all in a really strategic training plan. Let's break down each one of these steps. So, stage 1. We have to tackle that massive, noisy, raw data set. The goal here is just to do a first pass, a big, broad strokes cleanup. We use automated tools to get rid of the most obvious junk and find a smaller, much more promising core data set hidden inside. And the main technique here is something called multi-clustering. The best way to think about it is like this. Imagine you give the same pile of data to several different sorting algorithms. Each one is going to group similar data points together. The trick is you only keep the data that all of the algorithms agree on, the stuff in their intersection. This consensus approach is an amazing way to filter out the weird outliers that might fool just a single algorithm. And the impact of this first step is just massive. I mean, look at this. A raw data set of, say, 100,000 samples might get chopped all the way down to just 40,000. Yeah, we've tossed out more than half of it, but what's left is so much more valuable. This is that first big trade-off. You sacrifice quantity for a huge leap in quality.
All right, so now we have our grade C core data set. It's better for sure, but it's not good enough yet. To get to the next level, we're going to do something really clever. We're going to use AI to judge the data. That's right. Multiple AI models act like a panel of judges to find the highest quality stuff inside, what we call the core of the core.
So here's how that works. We take a bunch of different, powerful AI models, and we have them all analyze our core dataset. They each make a prediction, or a classification, for every single sample. And we only keep the data points where all of the models agree with super high confidence. This process gets rid of all the ambiguous data that might confuse a single model, and that dramatically reduces potential bias.
And again, look at the change. The dataset shrinks dramatically, from 40,000 samples down to 20,000. This right here is now our grade B data. The key isn't just that it's smaller, It's that it is incredibly consistent from an AI's perspective. This is the perfect workhorse dataset for the main phase of training.
We've made it to the final, and definitely the most rigorous stage of this whole process. We've got high-quality data that multiple AIs agree on, but to hit that golden standard, we need the ultimate judge of quality, a human expert.
This is what's called the human-in-the-loop stage. The AI-validated data is now passed over to human domain experts for a final inspection. And the rule is super simple. A piece of data only gets promoted to golden if both the AI consensus and the human experts agree that it is perfect. What comes out the other side is the golden dataset, the collection of data that we can truly consider the absolute truth.
So, after this final, incredibly tough check, our 20,000 samples might become just 8,000. This is it, our grade A golden dataset. I mean, just look at that journey, from 100,000 raw samples all the way down to this small, pristine set. Its quality is now totally unparalleled. It is the perfect seed from which a world-class AI model can grow.
Okay, so we've done all this hard work to create these beautifully graded datasets, right? From D all the way up to A. But filtering the data is only half the story. The real magic is in how we use these different grades. This system lets us be way more intelligent and strategic about how we actually train an AI.
And this brings us to a really, really important question. I mean, if the grade A golden data is so perfect, why even bother with the other grades? Why not just train our model exclusively on the best of the best?
Well, it's a classic trade-off between purity and practicality. Sure, if you use only the perfect golden data, you'll get super high accuracy and it'll train really fast. But the danger is a little thing called overfitting. Because the dataset is so small and so clean, the model basically just memorizes it. It becomes like that perfect student who can ace the test but can't solve a single new problem out in the messy real world. The key is strategically mixing the grades to build a model that's both accurate and adaptable. So, this leads us to what you could call a strategic training recipe. First, you build the foundation. You train the model on the grade A golden data so it learns the core patterns with perfect clarity. Next, you enhance it by adding in the grade B data to increase the volume while keeping the quality high. And then finally, you mix in some of that grade C data for generalization. This exposes the model to more of that real-world messiness, but the whole time, that golden data acts as a powerful anchor, keeping it from getting lost.
And this really gets to the heart of the whole thing. The golden dataset is so much more than just training material. It becomes the ultimate source of truth. It's the benchmark you use to measure the quality of all your other data, and it's the final exam you use to measure the true performance of your finished model.
So the next time you use an AI, whether it's a chatbot, a recommendation engine, you name it, just think for a second about what's going on under the hood. The quality of your experience probably comes down to this one simple question. Was it built on a mountain of raw data, or was it built on a foundation of gold?